In this video, we are doing lesson 5 using trig functions to solve angle of elevation and depression. So note that angles of depression and elevation are measured from a horizontal line. Also, because that they are alternate interior angles of parallel lines, they are congruent. So given that these two horizontal lines are going to be parallel to each other, our transversal from our last unit is going to create alternate interior angles. So for our example 1, is at a certain time of day, the angle of elevation of the sun is at 44 degrees. Find the length of the shadow cast by a building 30 meters high. So I'm going to attempt to sketch this situation. So here's our ground. We're going to have our sun, and with the elevation of 44 degrees, it is obviously not in the sky. It is slowly rising, sunrise. So here's our little sun. We have an elevation of 44 degrees. And that elevation of sunlight is hitting a building. And that building is 30 meters high. Well, we want to find the length of the shadow cast by the building. So the sun's going to hit the building on the left side, then create a shadow, kind of like my pencil's doing right now, kind of cast a shadow off to the right. Now this is going to create a 90-degree angle, and we can assume, because it's not giving me any other information, that this 44 degrees is going to be the same on the other side. Once this happens, we have our opposite side measurement from our angle. We have our 90 degrees, so we know that it's a right angle or right triangle. And we want to know how long this shadow is going to be. So we want to know how long the shadow of the building is going to be with the elevation of 44 degrees and from a 30-meter building. So we know our angle and the opposite side. We want to figure out our adjacent side. So find adjacent. So looking at what we know and what we've got to figure out, we've got opposite and adjacent. Well, opposite and adjacent tells us that we're going to have to use tangent. So we have a tan of our angle, which is 44 degrees. And then we've got equals to our opposite, which is 30. And then our adjacent, we've got to figure out. So we're going to get x by itself, first by multiplying x to get it out of the denominator. So we're left with x times tangent of 44 degrees equals 30. And then we can do the inverse operation of multiplication to get x by itself. These cancel out because anything divided by itself is just 1. and 1 is always understood. Now, in this video, I want to take the time to show you how to put this into Desmos. So I'm going to use my computer because obviously I'm using my phone to record this. So here's Desmos on the computer, and I'm going to type in what we had. So we had 30 divided by tangent. So either you can come down here to the ABC and type in tangent, or you can come over here to functions and click on tangent. And then we've got 44 degrees. Now, remember in the calculator we had to make sure that it was in the correct mode. Well, this is looking pretty high considering everything. But I want to make sure that Desmos is calculating in degree mode, not radian mode. So I'm going to come over to the little settings. And right now it's in radians. I want degree. So once I hit degree, it fixes my answer. And we have at 31.06, so on and so forth. Well, I'm going to continue. The problem does not say how to round, but I'm going to round it to the first decimal place, or the tenths place. So I have 31.1. So my solution is going to be 31.1. Now the problem asks, write an equation, then the solution. So my equation was my original definition of the trig function. So tangent, using the information that was given. So tangent of 44 degrees equals 30 over x. And then we found x equals 31.1. And that is example 1. Now for page 13, we've got example 2. Example 2, we have a 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What is the ladder's angle of elevation? So again, don't make fun of my drawing, but this is what it's saying for the picture. So our building is here. We don't know how big our building is, it's just there. Then we have our 20-foot ladder. We know that the ladder creates a 90 degrees with the building. And the base of the ladder is 8 feet from the base of the building. So from the base of the ladder to the building, it's 8 feet. We want to know the ladder's angle of elevation. So from the ground up, what is that angle? And I'm going to use theta. You can use x if you want to. So I know the hypotenuse, so across from the right angle, and the adjacent side of the angle identified. I need to find out the angle. So looking at what is involved, I have hypotenuse and adjacent. So that tells me my trig function I'm using is cosine. My angle, I don't know, so I'm going to use theta. And then I have adjacent, which is 8, over hypotenuse, which is 20. Now I want to figure out what theta represents. So to get theta by itself, I'm going to do the inverse of cosine. And what I do on one side, I have to do to the other. So these cancel out, and I'm left with theta on this side. Now, I'm going to use a Desmos or your graphing calculator to figure what this is. So I've already made sure that my settings is on degrees. So I'm going to clear out what I did in the last problem. I'm going to type in the inverse of cosine. I'm going to go back to functions and I'm going to find the inverse cosine. Then I have 8 divided by 20. So my answer is 66.421, so on and so forth. Again, I'm going to round to the nearest tenths, so I have to 66.4. Now, because I was working with angles, it is 66.4 degrees. And my question asked me to write the equation as well, so I have cosine theta equals 8 over 20. My solution is theta equals 66.4 degrees. For number 3, I'm going to create the picture. And again, I'm going to create my ground first. I'm going to draw my tree. And I'm sure most of you can draw better trees than I can. But from my tree, I have at a point on the ground 50 feet from the foot of the tree. So here's my point on the ground. And from the base of the tree to my point, I've got 50 feet. The angle of elevation to the top of the tree is 53 degrees. So from the top to the point on the ground, it is 53 degrees. Now I want to know what is the height of the tree. So I want to know this side. So what do I know? I know the angle. Also remember this is a right triangle. I know the angle. I also know the adjacent side. I need to find out the opposite side. Remember, opposite side is the side not touching the angle. So having the angle, adjacent, and opposite involved, we're using tangent. So we're going to have tangent of 53 degrees equals our opposite side over our adjacent side. So we're going to multiply by our denominator, multiply by our denominator. These cancel out, and we're going to figure out what this side equals. So we're going to go on to Desmos, clear out what we did in the last one, and we've got 50 times tangent of 53. And if you're going back and forth in this video, make sure that your degrees is selected. So our answer is 66.35, so on and so forth. So I'm going to put 66.4. So this side is 66.4, and that gave us x. Now, were we finding an angle, or were we finding a side? We were finding a side. So we do not put a degrees on this at 66.4. Up here for example 2 we did, because it was finding an angle. Down here we are not. So write an equation. We had a tangent of 53 degrees equals x over 50. And our solution was 66.4. Now this creates the question of which one's better to use when we're finding an angle. Well, when we're finding an angle, I prefer using a theta, because it reminds me at the end that I need to put either degrees or identify it as radian. When I'm using x, I know that I'm trying to find a side, not an angle. So I don't have to put any units with it or any sign with it. So pause the video and attempt examples 4 and 5. You should have gotten something similar to these. Now, we're going to move on to page 14. And you will attempt questions 1 through 6 on your own and check back on Canvas for the answers.